Chapter 2, Accumulator Functions. At this chapter, contents are overview, instruction T2, push, pop, enter and leave, arithmetic instructions, word logic instructions, increment instructions, bit rotation, forming the ones, negation of numbers, and so on. So at this picture you will see the overview of accumulator functions and commonly used toggle, push, pop, and these are affect only AQ1, increment, decrement, reverse order, forming the ones, invert and complement, and next page. With instruction toggle accumulator, you will see an example for step 7 300, and 400 is different because there are 4 accumulators. Before the command, variable 1 and variable 2 exchange after toggle command, accumulator 1 and 2, and this command is affect only first 2 accumulators. For step 7 400, accumulator 3 and 4 values remains the same after the command. And here is an example. Load contents of memory word 10 to accumulator 1, lower integer, and next command load contents of accumulator 1 to accumulator 2, then load contents of memory word 12 into accumulator lower integer because 32 bits, and check if AQ2 is greater than AQ1, jump conditional next, and subtract contents, transfer the result. Yep. Let's try this. Minus integer already used. So right now there is no jump. Yep, right now there is a jump. So via this way, you are always sure you subtract from greater number than the less number and result always be positive. Subtract the smaller value from larger value. Next instruction, push and pop. You will see at the image before comment and after comment. It's a little bit different at step 7 400 family, but it's similar. And only for step 7 400, enter and leave affects all of the accumulators. And arithmetic operations and instructions like plus, minus, division, multiply affects the first two accumulators. And it's important to know the values of accumulators at step 7 400 after instruction executed. That's the difference. And word logic operations, instructions, and or XOR. The behavior at step 7 400 is different when you compare to arithmetic instructions. Like this. And another very commonly used instructions, change word order or exchanged bytes of accumulator 1, low low, low high, high low, and high high bytes. There are 4 bytes. And change word instruction affects the first 2 bytes. That means the low side. Change double instruction affects all of the 4 bytes, as you can see with arrows after comment. So in real world schematic programming language, number format of Intel programming language, especially data transfer between PLC and PC, for instance between step 7 PLC and WinCC, you need to use these commands to change the byte order to get the correct values. And next command, increment instruction for accumulator 1, increment and decrement. And sometimes you need to ones complement, that mean invert as integer, invert as double integer, And 2's complement, that means negation of numbers like this, is also possible with real numbers for exponent side, and Mantis side still be the same. Rotating instruction works with code condition 1 bit. Left or right command is possible, and for carrying the least significant bit or most significant bit, the interpreter or PLC uses CC1 bit to carry from last to first or first to last. There's an example: rotate left for accumulator 1. After command, it becomes like this. Yep. And at this case, CC1 bit is important. CC2 and overflow bits are reset to logic level 0. And exercise for you: calculation of exponents. Form 6th power of an integer. Use of push and multiply integer. This is the task and what you should do step by step. And next exercise for data exchange in accumulator 1. Next exercise, forming the complements. And before we go to next chapter, we can make some exercise and small program applications. So let's say load double and okay. Let's take a look like in okay. Yep. Alright. first byte, second byte, third byte. It's from left to right, and the decimal number is this. Okay. And this is the exchanged byte order from the after the instruction. The first byte, second byte, third byte, and the last byte. And change word instruction, the high side remains the same, only the first 2 bytes exchanged. Okay. And for rotate instruction, let's load a constant.